Hey students, guess what time it is? It's science time. Get out your notes and let's start learning. Remember back to when you were doing the problems with the different objects and trying to find out what is the number of each one of those objects. We're using units such as like the grams, dozen, and finding out from that how many individual particles there were. Now in chemistry, we're going to be using a unit called a mole. And this is something that I had mentioned here a while back. If you remember clear back towards the beginning of the year, there was even a mention about this when we were starting going over fundamental units. And a mole is one of those fundamental units. Now, the mole has nothing to do with the little rodent. Now, it's spelled M-O-L-E, is abbreviated as M-O-L because apparently writing the E is a little bit too much effort. So I don't know why they dropped the E, but that's the way it is. Now, don't try to abbreviate it as lowercase m because that can be confused with meter, or there's also a unit of concentration called a molality that can also be confused with that here. So a lot of times you just write it as MOL. Now, a mole is a counting unit. So the definition of a mole is the amount of a substance that contains the same number of particles as the number of atoms in exactly 12 grams of carbon-12. If you remember something like for the gram was originally based upon 1 milliliter or 1 cubic centimeter of water. The mole is also a fundamental unit and is based upon was originally based upon 12 grams of carbon-12. Now that was also the video that you saw where that silicon sphere. Um, so now they end up changing the definition, but this was the original definition of it here. So they just recently changed the definition here within the past couple of years, what it's going to be based upon. But for now, just know it's 12 grams of carbon-12. So what they basically did is they took 12 grams of the isotope of carbon-12. So carbon-12 has 6 protons and 6 neutrons in its nucleus. And they count out the number of atoms within it. And that number is what's referred to as being 1 mole. So carbon-12 is the original fundamental unit of a counting unit. So it's just like saying a dozen. And if I were to say 1 dozen, that's 12. If I were to say a baker's dozen, how much is a baker's dozen? That's 13. There's also other words that we use to represent counting units as well. There is a unit of a gross. And a gross is basically a dozen by dozen, or 144. Sometimes they sell packs of pencils in grosses. In other words, those are packs of 144. There is a unit called a ream. A ream means 500. So, like for example, like a ream of paper. So a mole is just as a counting unit, just like saying, a dozen is 12. A mole is a much larger number. What number is that, you might ask? Well, that is this number up here. And the number is 6.022 times 10 to the 23rd. I'll write that for you here in a little bit. But this is referred to as Avogadro's number. And Avogadro is the one who had figured out how many atoms there are in 12 grams of carbon-12. Okay, so the mole was originally based upon 12 grams of carbon-12. And what they ended up doing was they took a scale and they placed on top of it a mound of carbon-12. So this is just one isotope of carbon. And when the scale read 12 grams, it said we're going to use carbon-12 as the fundamental unit. And if we have 12 grams of carbon-12, we will define this as being 1 mole. So the next challenge was how many individual atoms of carbon-12 were present within this. And a person by the name of Avogadro is the one who figured out a technique of how to go about figuring out how many atoms there were inside of here. And what he found out was 1 mole is equal to 6.022 times 10 to the 23rd. And that's how many atoms that were present within that. So to give you an idea how big of a number that is, that's 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's how many atoms there are present in 12 grams of carbon-12. It would be physically impossible for a single individual or even for groups of individuals to sit down and count out 1 mole of stuff here. So for example, 1 mole of table salt would roughly fill up your hand. So if you just cup your hand, pour some salt into it, that would be roughly 1 mole that you will be holding on to. And if you were to take that handful of salt and go around and distribute to every single man, woman, child on the planet, so each person will only get just a couple grains of salt, maybe even less than that. And their job was to sit down and just those few little grains of sand would count out the number of molecules within that. It would take them roughly 2.5 million years for every single man, woman, and child to count out every single molecule of salt within just those few little grains of it. So a mole is a huge, huge number. But that is what much of chemistry and even much of physics is based upon, that number. So it's the number of particles in exactly 1 mole of a pure substance. In other words, 1 mole is 6.022 times 10 to the 23rd. Just like 1 dozen is 12, or 1 baker's dozen is 13. So it's just like saying 1 dozen is 12. Instead, we're going to say 1 mole is equal to 6.022 times 10 to the 23rd. And because that's an equality, we can use that as a conversion unit later on. So again, exactly 12 grams of carbon-12 contains 6.022 times 10 to the 23rd atoms of carbon-12. So this part right here, 1 mole is equal to this value, is just like saying 1 dozen is equal to 12. Now, if you remember back when last week when you were working on this, okay, and across the top I had you write down grams, dozen, number of objects. And 1 dozen is equal to 12 objects, and then X number of grams is equal to 1 dozen. Now, this value of X came from here. This was your value of X. And so if you have 15.67 grams of paper clips, they'll go right here, and you would have 1 dozen. And this will allow you to go from grams to dozen, dozen to number of objects. And remember, whenever 2 values are equal to each other, you can set one over the other one. So that one unit will cancel out, and the other one will remain here. And so this will allow you to switch from grams to dozen, dozen number of objects. So what we're going to be doing is the same thing. Is right up here. Just copy this down again. Grams, dozen, number of objects. So we go in between here and between here. 1 dozen is equal to 12 objects. And here, X number of grams is equal to 1 dozen. For X will vary depending upon the substance you have. So in chemistry, we're going to be using grams, moles, and the number of particles. Now, particles can be anything. This could be atoms, it could be molecules, it could be ions, it could be people, it could be donuts, it could be cars, it could be anything. but a lot of times you're just sticking with basically molecular and atomic objects here. So in order to go between here, just like 1 dozen is equal to 12 objects, we're going to have 1 mole is equal to 6.022 times 10 to the 23rd. And for right now, I'm just going to put down particles. Again, later on we'll be using atoms. Sometimes we'll be using molecules here, but this is just kind of like a filler here. It's just like saying objects, which could be donuts, cars, people. And here, X number of grams is equal to 1 mole, just like X number of grams is equal to 1 dozen. So here, previously, we were using this value here. But now, when we find that, it's here. That is these numbers down here on the bottom. Now, you're also going to hear another unit. It's called a molar mass. And if you look at the name of it here, basically what it means is a mass of 1 mole. So it's a mass in grams of 1 mole of an element. And so sometimes you may hear it called something else. Sometimes they call it atomic weight, atomic mass, formula weight, molecular mass. Basically, it's not technically correct here, but mass and weight are almost used interchangeably here. And sometimes you're going to be talking about atoms. Sometimes you're going to be talking about the formula or the molecule of a compound here. You're basically dealing with the same thing here. But this molar mass is what you see when you look at the periodic table. It's the numbers that appear in the bottom portion of the periodic table. So if you remember, typically towards the upper part of the periodic table, you have the atomic number, which is the number of protons, which also happens to be equal to the number of electrons. But there is also another set of numbers on the periodic table, and that is its atomic weight or atomic mass, or whatever. Basically, it's formula weight. So that is when you're weighing out the different items, for example, like the paper clips and the napkins and the pennies. And when you're looking at those different items, when you're measuring out 1 dozen of those items, you'll find out how many grams was 1 dozen. That's the same thing with this. So with the items, you had to weigh it out. This has already been done for you, and that's what you see on the bottom portion of each block in the periodic table. So that number, like for hydrogen, is 1.0079. You might not be able to see that too well here, but that unit is a gram is equal to 1 mole. Or technically, that is, the unit for that is, like for beryllium, 9.012, and units for that is a gram per mole. That's grams per 1 mole, or saying the same thing as how many grams is equal to 1 mole. So this right here is my X value. So all these are different X values that you can possibly use within this chart here. So just like all of these were my X values. Like for my binder clips, this is my X value here. For my pennies, this was my X value. So different objects had different values for X. So just like on the periodic table, the numbers on the bottom are my X values here. I'm going to be plugging into here. And this will allow me to switch from, if I know how many grams I have, how many groups do I have, and then how many individual particles do I have. Just like, if you have, if I have 24 washers, so I can find out how many dozen washers do I have, and if I knew how much did a group of washers weigh, I can find out how many grams or how much would it weigh. So the same thing with this. If I know how many atoms or molecules I have, I can find out how many groups do I have, and then find out how much does it weigh, or vice versa. So by weighing, you can count how many objects do you have. And this is used rather extensively throughout chemistry. Alright, so let's give these a try, and if you have any questions, just email me.